Okay, starting this video on number 18. If you want to see a number before number 18 on the chapter test, then watch the video before this. So for number 18, it says, suppose A equals, or suppose the set A is all numbers x greater than -1, and so A is all numbers x greater than -1. And B, oops, that's a D. B is all numbers in between, looks like -3 inclusive and 2. Alright, so the question is, which statements are true? Well, the first one says A union B equals the null set. Well, the union of A and B would be all things in A and all things in B. So that's actually going to be a huge amount of things. So it's definitely not this. This is not true. The next part says A prime equals x is less than -1. A prime is the complement, so it means every number that's not in A, in the universal set in this case. So if A is numbers greater than -1, A prime should be numbers less than or equal to -1. So if it had or equal to, that would be true, but since it doesn't have this, this is not true. Alright, that was a tough one. So now we have A intersection B equals numbers that are in between -1 and 2. So let's see, the intersection of these means they have to be greater than -1. Yeah, that's true, because these numbers are greater than -1, and so are these. And they also have to be less than or equal to 2. So these are less than or equal to 2, and some of these numbers will be. So the intersection, that is correct. So I think this one is correct. Now, just to double check, I'm going to check the fourth one to see if we're right. And it says B is a subset, that's like a C there, not a less than, is a subset of x is less than 2. Alright, so if B is numbers that are less than or equal to 2 and greater than or equal to -3, would B be a subset of numbers that are less than 2? Nope, because B includes 2, whereas this does not include 2, right? So if you look up here, this is a close one, this is a tough one. B does include 2, so B needs to be a subset of something that also includes 2, which this does not. So this one is not true, leaving C to be the only correct choice. That's actually a pretty tough problem there. You got to really reason out each one of those. For 19, we've got 4k minus 2 in absolute value equals 11. So remember, this is not a less than or greater than, this is an equals. So we know that everything in here has to be equal to 11, or it could have been equal to -11, except for those absolute value symbols changed it, right? So these are the two choices. And then we solve, so I'm going to add 2 to both sides. Divide by 4. And then over here I'm going to add 2 to both sides. And divide by 4. And it does not say to graph. It says to check your solution. So we can check it. 13 over 4 times 4 would be 13, minus 2 would be 11. Over here, -9 over 4 times 4 would be -9, minus 2 would be -11, absolute value of which would be 11. So those are correct. For number 20, says, this looks pretty similar, 23 equals n plus 10 in absolute value. So the same thing is going to be true. N plus 10 is going to equal 23, or it could have equaled negative 23 before the absolute value affected it. So I'm going to subtract 10 from both sides. And those are my answers. It says to check my solution. So 13 plus 10 is 23. That's true. Negative 33 plus 10 is negative 23, but then these absolute value symbols would make it positive. So these are correct. Checking number 21. This one says 3c plus 1 minus 4 equals 13. So a lot of you are going to try to make your OR statement or your AND statement now. Don't do that. I tell you only to do that after you've isolated the absolute value. So first thing we're going to do is add 4 to both sides. Now we have our isolated absolute value and we can make our OR statement. So that stuff equals 17, or the stuff inside equals negative 17. Subtracting 1 from both sides, dividing both sides by 3. Over on this side, I'm adding subtracting 1 from both sides again, dividing both sides by 3. So our answers are 16/3 or negative 6. To check them, 16/3 times 3 is 16, plus 1 is 17, minus 4 is 13. Negative 6 times 3 is negative 18, plus 1 is negative 17. Absolute value makes it positive, minus 4 is 13. So they're both correct. Alright, number 22. We've got 4 times absolute value 5 minus t equals 20. Again, before you make your statement, you need to isolate the absolute value. I'm going to divide both sides by 4. That leaves me with 5 minus t absolute value equals 5. Now I'm going to make my statement. So 5 minus t could certainly have been 5, or it could have been negative 5. Subtracting 5 from both sides here. Now multiplying both sides by negative 1. Over here, subtracting 5 from both sides. I'm multiplying both sides by negative 1. Alright, let's check these. So 0, 5 minus 0 is 5 times 4 is 20. That's correct. This one, 5 minus 10 would be negative 5. Absolute value making it positive 5 times 4 is 20. Those are good. Alright, 23. Let's see, a drama club wants to raise at least $500 in ticket sales, so they need 500 bucks. The members of the club sold 50 tickets at a special $5 rate, so 50 at $5. The usual ticket price is $7.50. At least how many tickets do they have to sell to meet the goal? So we need to sell X tickets at $7.50. This is set up because it says at least how many. It's kind of a forced way to set up an inequality question as a word problem. You can solve it as an equation by saying 50, right, from here, 50 times 5, which is how much you've already sold, plus 750 times X is going to equal 500. They want you to say like greater than or equal to 500 because you could obviously sell more tickets to meet your goal. But to meet the goal, this is what you need to do. So this is going to be, what, 250 plus 7.5x greater than or equal to 500. Subtract 250 from both sides gives you this. Divide both sides by 7.5. Not sure exactly what that is. It's going to be 2500 divided by 75. So what is that? 150, 225. So 250 again, so 225, 250. So it looks like we're going to have a repeating decimal. So, oh, I see. Okay, that's what makes sense. So in order to get to your 500, you need to sell 33 and a third. Well, obviously you can't sell 33 and a third tickets, so you're going to need to sell 34 or more tickets at that price, right? So 34 or more tickets, or at least 34 tickets. Number 24. Of 145 runners, 72 only on weekends, 63 both weekends and weekdays. Weekends and weekdays. Okay. And our question is, how many of the runners run only during the week? This type of problem is easily solved with a Venn diagram. So make two circles here. Those are pretty ugly circles, but you get the idea. So there's 145 runners total. We'll get to that number in a moment. But let's say we have people that run only on weekends, and then let's see. Let's change that. So we'll make this weekends and weekdays. So only on weekends would be 72. Now if 63 are both weekends and weekdays, that's in the middle here because this is ends and weekdays. Notice not to be confused with the only weekends people. So these do both weekends and weekdays. And there's 145 runners total, so we need to figure out what goes, how many people run only during the weekdays. Well, if there was 145 total, and 72 of them run only on weekends, that leaves 73 left, but 63 of those run during both of these times, so 10 are left over to do just the weekdays. And so you'll notice if we add all these together, we get 145. So the answer is 10. All right, 25. I'm not sure how much time I'm taking here. I'm going to make this video less than 15 minutes, so if it goes over, I'll just have to cut these last few out here. Write an absolute value inequality that has 3 and -5 as two of its solutions. Well, so I need to have 3 and -5 as two of its solutions. Okay, I'll just make it really big. So both of these needs to be in the solution. So I can say x is greater than -6 and less than 6, so that would be one of these. Here we go. That's it. 26. Compare and contrast the multiplication property of equality and the multiplication property of inequality. Well, both allow us to multiply both sides of an equation or inequality by a positive number. The contrast or the difference is that if you're multiplying an inequality by a negative number, you have to change the direction of the inequality symbol. I'm not going to write all that down, but you get the idea. You can listen to that again if you want to hear the answer. Number 27, describe the region labeled C in terms of set A and set B. Okay. Well, here's set C, and then A and B are kind of over here. So if A and B are here, if the union of A and B, this is kind of a tough one. If the union of A and B includes everything in those circles, then C would be the complement to that, right? So that's the answer for that. A union B complement. That's kind of a tough one. 28. Suppose set A has 9 elements. What is the greatest number of elements a